Eitan Satchard, the originator of the geometric Chronon field theory, has taken my original work in the 1980s and extended it beyond recognition. It is definitely 90% his work. I'm therefore happy that the Chronon field theory is in good hands. There's a book published 2 months ago, sponsored by the Vaknin-Rangelovska Foundation, which summarizes the state of the art in Chronon field theory as of 2 months ago. Eitan is hard at work, revising the theory daily almost. So there's a link in the description if you want to download the book and give it a go. Chronon field theory. I have moved on into a new project, and today I would like to discuss this project with you, because many of you, surprisingly, are as interested in my work in physics as you are in my work in psychology, which never ceases to amaze me. And so I'm, in the past few months, as of the beginning of this year, I'm in the throes of a completely new project. This video that you're watching is the introduction, and if you want to watch the full video, there's a link in the description. The introduction, I hope, is a little more accessible than the full video. So, 40 years ago, influenced by my conversations with Yakir Aharonov and Richard Feynman and other giants in physics, I was fortunate to spend a lot of time with them. So 40 years ago, I suggested that the brain is electrochemically built to perceive only collapsed states of the wave function, only what is known as pointer states. The brain filters out the other eigenstates. Now, those of you who are into physics, even minimally, are aware of phrases such as the wave function and superposition and so on and so forth. And you know that the state vector is a kind of map or kind of list of all possible states with attendant probabilities. There's like a list of states, and each state has a probability, 5%, 1%, whatever. So the state vector is replete with one essentially deterministic collapse state and many others which are probabilistic. The collapse state is also probabilistic, but the measurement renders it deterministic. Anyhow, in my work, the collapse state is the only one detected by the brain in any reduction of the superposition. It's as if the brain, this device inside our skulls, has a limitation, has a constraint. The brain can detect only collapsed states. It cannot detect any other states. So when we look around in reality, when we measure things in laboratories, and when we observe all kinds of processes, such as elementary particles in accelerators and so on and so forth, we keep saying, wow, this is a collapse state, this is a collapse state, this is a collapse state. And probably our measurements are creating this collapse. They're involved somehow in collapsing the state vector, in reducing the state vector. And this is, of course, the famous Copenhagen interpretation. Any attempts to evade or to avoid this conclusion lead to seriously mystical and metaphysical interpretations, such as the many worlds theories and so on and so forth. But what I'm proposing is much simpler. What I'm saying is that the measurement devices, our brain, and by extension our measurement instruments, and even inanimate and animate observers which are not human, any act of observation or measurement, and especially acts of observation and measurement committed by our brains, would be subject to the limitations of our brain. And our brains are incapable of detecting or perceiving or interacting with states in the state vector which are not collapse states. We can detect, measure, observe, and record only collapsed states. If we adopt this point of view, it revolutionizes the field, because it suddenly explains so many conundrums and so many philosophical problems that have been plaguing the field since the 1920s. Anyhow, this is my point of departure in my work. All the states in the state vector, in the eigenvector, all the states are of equal ontological status. All the states are equi-ontological. They ontologically speaking, they are equal to each other. There's no privileged status. And all the states are equally available for measurement. And yet the brain, all the measurement devices, or the observers, and so on, they select only one state at a time. And that is the collapse state. Why is that? Why do we select for a collapse state? Why the apparently privileged position of a collapsed or pointer state as far as our brain or consciousness or mind or measurements go? Why do we keep measuring collapsed states? Why do we have a preference for it? Structural preference, functional preference, evolutionary preference. Well, because collapsed states are conducive to survival. Collapsed states are relatively stable, and they increase order and structure in the universe. They are negentropic. It is true that unstable states can also collapse, but it's much more rare. The vast majority of collapsed states have a longevity which is far greater than the longevity of non-collapsed states. So most of the collapsed states increase order, increase structure, are stable, and therefore by definition are conducive to survival. All other states are fleeting, ephemeral. They immediately decay and degenerate, and they end in entropy or the increase of entropy. Entropy is the enemy of life. The universe seems to have a preference for negentropy, the opposition to entropy. The universe seems to have a preference for order and structure, at least locally, in local pockets. And all this, everything I've just said, can be captured not only with classical tools, and not only with quantum mechanical formalisms and so on. It can be captured using mathematical instruments borrowed from information theory and thermodynamics, coupled with dynamics of complex systems, mainly attractors, especially strange attractors, both chaotic and non-chaotic. We'll come to it in a minute. Anyhow, in my work, the collapse state would be a signal. It's a signal because, by definition, it increases order, it enhances or buttresses structure, it is negentropic. So it's a signal. It carries information. Whereas the non-collapse states would be the noise. They're entropic, and they do not convey information. Because they don't convey information, they cannot be captured by the brain. Whereas the collapse states are signals, and our brain is the ultimate signal detection system. And this leads me to the crux or the gist of what I'm doing. I said to myself, as a Gedanken experiment, as a thought experiment, if we were to construct an implantable computer chip or biological chip, doesn't matter, that would allow the brain to perceive the entire wave function, the collapse and non-collapse states, the whole wave function, rather than merely the ultimately collapsed states. if our brain could detect the totality of the wave function, all the probabilities, we would be creating a very powerful quantum computer with each and every one of the 70 billion neurons, the equivalent of a qubit. So this was the thought experiment that started me going, more or less in February this year. Now, of course, I'm not an engineer, and I don't know how to build such a computer chip or such a device, nor am I implying that such a device is at all achievable or doable. This is not an engineering approach. This is a mathematical approach. I'm working on the mathematics of such a chip, such a computer chip. And it is clear already that this computer chip should serve as a filter. It should somehow differentiate noise from signal. And I've chosen to use a PLL mathematic approach. So I'm using mathematics that describes PLL chips. I'm also using strange attractors for the pointer states and strange non-chaotic attractors, SNAs, for the non-reduced eigenstates. I treat the non-reduced eigenstates as noise with Sinai-Ruel-Bowen probability measures, for those of you who want to play a bit with all this new thinking. So there's a chip, and it's a PLL chip, it's a filter. And the question then arises, my good friend and collaborator, Eitan Sachad, asked me last night, but how would such a chip interact with non-collapsed states? Well, the answer is, it doesn't have to. It definitely would not interact with non-collapsed states in the Newtonian sense, like action, reaction, or detection, or whatever. There will not be real-world interaction. There's no need for it. All the eigenstates are already specified very accurately by the equation. There is no need to interact with them. There's no need to detect them, because we already know where they are, and we already have all the information about these states. One of them would collapse, but the collapse, as I said, is a reflection of the limitation of our brains and measurement devices, not a feature of reality. The collapsed state is not a feature of reality. It's a reflection of limitations. Theoretically, if we were to have a godlike brain, we would probably see the entire universe in a state of collapse, immediate collapse of every single possibility. Anyhow, coming back to us and to the chip. There's no need to detect the eigenstates. We know exactly where they are. We have all the information about them with the probabilities and so on and so forth. What we do need to do, we need to construct a chip that would cause the brain to perceive all states as if they were collapsed states, pointer states. In other words, we need to deceive the brain by constructing a virtual reality in which all the states are collapsed. All the eigenstates, the whole state vector is reduced, not only a single element. In other words, the brain will not reduce the eigenvector to a single collapsed state, but to multiple collapsed measurable states. At least that's what we want the brain to think. That's how we want the brain to perceive reality. This would require, of course, deterministic formalism of quantum mechanics, but I don't think it's much of a problem, because the wave function is already deterministic, actually. Okay, what would we achieve by doing this? The brain suddenly would be open to an infinite number of realities, all of them as real as the next one. Such a multiplication of collapsed states will exponentially explode the brain's computing prowess. The brain would be able to calculate, weigh scenarios, and zero in on solutions along an infinite number of branches. The brain will be rendered a quantum computer of immense, literally infinite power, with 70 to 80 billion qubits at its disposal. Just to remind you, the current record is 6,000. So that's where I'm going. This is my new focus and new concentration nowadays, when I'm not dabbling in narcissism and psychopathy and other cheerful subjects. And I'm focused on the mathematics. I just want to create a mathematical specification of a possible chip which would allow the brain to actually interact with the state vector as if the state vector is 100% deterministic and not probabilistic. In other words, a brain that would regard every possible state as having already existed or as existing. A brain which would endow and bestow an ontological status on what in the current formalism are probabilities. And I think that's the bridge that would lead to leveraging the brain as the next stage in artificial intelligence, or at least the next stage in quantum computing, leveraging the brain as a quantum machine. I'm saying artificial intelligence because this kind of brain, with this kind of computational power, would no longer be recognizable to us, and in this sense would be, of course, carbon-based artificial intelligence. It's the question of artificial intelligence. I, first of all, seek to expand the meaning of artificial intelligence and suggest that artificial intelligence is not only the use of devices, silicon-based or otherwise, devices to effect or effectuate or imitate intelligence, but artificial intelligence is also when we coax and reprogram and rewire our brains to work in ways which they haven't before. And I mean fundamentally, not teaching a new skill, not enhancing the general fund of knowledge, but forcing the brain to solve problems in ways which are unprecedented and have never happened before. I suggest that any technology that can make use of the brain as a platform, can make use of the wetware as a hardware, is artificial intelligence. I suggest that there is no difference or distinction in principle between a silicon-based platform and a carbon-based platform if they're both doing the same thing. And what they're doing, these platforms, is solving problems. Solving problems either at increasing speeds, that would be quantum computing, or in novel ways. And that would be, in my view, artificial intelligence. So the brain is capable of artificial intelligence if we find a way to reprogram it. Not only that, but the brain has the potential to become the most potent, powerful, mighty quantum computer because of the trillions upon trillions of synapses and billions upon billions of neurons. The brain is actually, even now, the biggest computer ever. In terms of computing power, nothing comes close to the brain. And if we were to find a way to change the path, the method that the brain uses to think and to solve problems, then we will have a double yummy. We will have artificial intelligence that resides on a quantum computer, and this quantum computer will be the biggest ever. In principle, there could be no bigger, more powerful quantum computer should we be able to convert the brain into one. Eitan told me the other day that the Aharonov-Bohm effect supposedly affects the wave function of an electron even before the collapse of the wave. And that triggered me in some ways to think, and so on and so forth. And I would like to describe to you today what I've been doing in the past few months and whatever triggered Satchel's response. A bit of a historical background. I have spent many hours with Yakir Aharonov and with Richard Feynman, and their work has had a profound influence on my Chronon field theory, which I postulated in 1982, 1984. The Chronon field theory, of course, is a potentials theory, though without any gauge. It's not a gauge theory, but it's definitely a potentials theory. So while I was working on Chronon field theory and debating the physicality of potentials, are they physical or just mathematical constructs, and rewriting physics using a new language with a single word, time, and considering that there's no such thing as particles or mass or motion or velocity, or these are all manifestations of potentials that eventuate, that become events. So in my mind there was a revolution going on, and then it occurred to me as a sideline, and it's not even in my original work. It's in a few notes and articles and later YouTube videos that I made. But 40 years ago, I suggested that the brain is electrochemically constructed to perceive only collapsed states, the collapsed states of the wave function, the pointer states. What I suggested is the brain filters out the other eigenstates. You remember that there is a superposition as the wave function evolves. There's a superposition of a variety of possible states. Each state has its own probability function. And so what we get is a vector, the state vector. And what the brain does, it filters out some of the states, actually all of the states included in the state vector, with the exception of the state that would later prove to be the collapse state. The state vector is replete with a deterministic collapse state, which is the only one detected by the brain. Now that's a bit of a revolution in thinking, because to this very day we tend to believe that the act of measurement, is the one which either determines, in the Copenhagen interpretation, or at the very least detects the collapse state. Whereas what I'm saying is that we are incapable in principle of apprehending or perceiving any other state except the collapse state. So we walk around, we traverse the universe, we bestride our planet, we go through our lives all the time detecting only collapsed states. And of course, by implication, ignoring or filtering out, it's like a membrane, filtering out states in the state vector which are not collapsed or are not likely to collapse. That led me to the next Gedanken experiment, to the next thought experiment. What if we were to construct an implantable computer chip that would allow the brain to perceive the entire wave function, the entire state vector, all the eigenstates, the total superposition, everything, not only the collapsed states, but all the states. We would be actually creating a very powerful quantum computer with each neuron serving as a qubit. Now imagine, right now, the state of the art is 6,000 qubits. The brain has 70 to 80 billion neurons. Imagine a quantum computer with 70 to 80 billion qubits. You can't imagine it. No one can, not even a quantum computer. This is it. This is the ultimate. It cannot be exceeded and will never be. How can we convert the brain, which is essentially perceived wrongly or rightly as an analog machine? There are quantum effects in the neurons. There's no debate about this. But all in all, the brain is perceived as a non-quantum machine. How can we convert the brain into a quantum computer? By allowing the brain to detect superpositions, by allowing the brain to gain access to all the probabilities, all the probable states, all the possibilities, all the eigenstates, all the totality of the state vector, including, of course, the collapsed state, but not only the collapsed state. There is, of course, a debate. Proponents of the many worlds theory and so on would say that all the states in the state vector are actually collapsed states, but in different universes, and so on and so forth. I'm not going into all this. This is too metaphysical for my taste. The fact is that we end up measuring and perceiving a single state. And we call it the collapsed state because there is a reduction of the state vector. And what I'm proposing is to find a way to coax or persuade the brain or rewire or reframe the brain or do something to the brain to force it to suddenly apprehend, suddenly perceive all the states, all of them, all the parts of the wave function, all the states in the state vector, anything that could have happened, all probabilities, simultaneously, to perceive all these. And this, of course, would open enormous avenues for super speedy and super complex computations, which are, at this stage, totally impossible with analog, regular computers, and even with the quantum computers that we have today, which are pitiful. Yeah? So the first stage, I'm not an engineer. I'm a very poor engineer, if any. I'm an even poorer geometrist. I think mathematics. My thinking is algebraic and arithmetic and logic. I'm good at these things. So the first thing, of course, I'm not capable of designing such a computer chip that will be implanted in the brain and converted mysteriously and magically into a quantum computer, change the programming of the brain to apprehend and perceive superpositions, not only collapsed states. I'm very unlikely to come up with such a chip. But what I can do, and I can do pretty efficaciously, is I can work on the mathematics of such a chip. In other words, I can create a mathematical construct which would be the equivalent of such a chip. The chip has to be a PLL chip. It's a filtering chip. And I would need to use mathematical techniques which are borrowed from far-flung outliers in mathematics, such as chaos theory. So I started a few months ago, I started my work on this, trying to design a computer chip in the form of a mathematical construct, or mathematical theory, if you wish. And I'm using now strange attractors for the pointer states, and SNAs for the non-reduced eigenstates. And I treat the non-reduced eigenstates, I treat the states which are not collapsed, I treat the parts of the superposition which don't end up being measured. Yeah, I treat them as noise with Sinai-Ruel-Bowen probability measures. So I'm telling you all these things. Those of you who are adept at mathematics and physics would have a field day and enjoy themselves, I hope. So at this stage, my focus, I think the right trajectory or path, mathematically speaking, would have to involve something like chaos theory and non-chaotic attractors. Strange, but non-chaotic attractors. Because what I propose is to treat the state vector or the superposition, to treat them as a noise to signal, as a kind of, to use information theory, to introduce information theory, and to treat the whole situation as a noise and signal. The signal is the collapsed state. The noise are the non-reducible, non-collapsed states, the non-reduced eigenstates, and then we have already probability measures and mathematics to deal with this. And what determines the collapsed state? Here comes chaos theory with or complex dynamics, dynamics of complex systems, where we have the use of attractors. And of all the attractors, I found strange attractors, chaotic and non-chaotic, to be the most useful, where non-chaotic ones apply to the noise and chaotic ones apply to the signal, which is the collapsed state. I'm just at the very beginning of this, and it would take a few years, I think. But I will end up with a mathematical specification of a PLL, a filter chip, that would be able to open up the vista of the state vector, open up the vista of the superpositions to the brain, to render them accessible to the brain. Of course, this immediately, those of you who are so inclined, immediately you can see that this has predictable similarities to the mathematics in my Chronon field theory, and also to the math in the geometric Chronon field theory, which is Eitan Sachar's work, not mine. So I said that the chip, at this stage, may I remind you, I'm not building a chip. I'm not capable of it. I don't have the capacity financially, and I don't have the capacity intellectually. I'm not a good engineer. I'm not an engineer at all, actually. But when I say the chip, I mean the mathematical construct that represents the chip. So the chip in my nascent work and this work that I've just started is a PLL. It's a filter, and this raises the question: how will this chip interact with non-collapsed states? And this leads me to what Eitan Sachar wrote to me yesterday. He said he mentioned the Aharonov bomb effect. Well, I think it's the wrong way to look at it. I don't think there's a need for an interaction. It's not that the filter will interact with non-collapsed states, definitely not in the Newtonian sense, action, reaction, and all this. All the eigenstates, or the totality of the state vector, all these states are already provided, predicted, described very accurately by the wave function, by the equation, Schrödinger and later. So it's not like we don't know anything about these states, and we need to kind of measure them, investigate them, interact with them, prod them. That's completely untrue. We know everything there is to know about each and every component of the superposition, each and every state in the state vector. We have full information. So it's not about the filter. The filter is not about obtaining information from the, let's say, from the superposition or from the state vector. It's not a process of interrogation. We have a very accurate description, mathematical, probability, everything. So no need to interact with these states. But what the chip needs to do is to force or to cause the brain to perceive these states, and to perceive them as if they were collapsed, as if they were a reduced part of the state vector, as if they were pointer states. In other words, the aim of the filter, the PLL filter, would be, if you wish, to deceive the brain into believing that every portion of the superposition and every state in the state vector is actually collapsed, is actually reduced, that the reduction is total. The whole superposition collapses, if you wish. All the states become equally real, equally measurable, equally accessible. Now that's not true in reality. And because it's not true in reality, I'm using the loaded phrase, deceive the brain. This is not true in reality. But if we were to convince the brain to access this virtual reality where superpositions are actually positions, everything happens simultaneously. Everything happens simultaneously, regardless of the probability. And the whole wave function collapses and the whole state vector is reduced, and every single possibility becomes real in this virtual space, not in reality, tangible reality out there, but in this virtual space. So the role of the filter would be to construct a virtual environment, and we know how to do that by now. Construct a virtual environment within which superpositions lose their probabilistic nature and become deterministic. Every single state, every single eigenstate, every single state in the state vector comes to be, regardless of the probability attributed to it in the wave function. Comes to be because everything is reduced, and in effect, the superposition cancels itself. The state vector collapses. The state vector collapses. Not the states, not any specific state, but the whole state vector collapses. In this virtual reality, anyone who has experienced virtual reality knows it's easy to deceive the brain. You believe that you are falling from a high building, or you believe that you are drowning easily in virtual, or you believe that you're in the Middle Ages. It's very easy to deceive the brain. And I want to deceive the brain using this PLL chip to actually misperceive non-collapsed states as collapsed states. That minute, the total computational capacity of the brain will be at the disposal of each and every state. And that is a great definition of quantum computing. At that point, 70, 80 billion qubits would be available to process every single state in the state vector, every single eigenstate, every single element in the superposition, as if they were all 100% real, 100% probable. And of course, the computing power here is mind-boggling. In other words, we don't need to reduce the eigenvector to a single collapsed state, but we need to reduce the eigenvector to multiple collapsed measurable state. Measurable by whom? Measurable by what? Measurable by the brain. Is the measurement real? No, it's not. It is simulated by the chip. But it doesn't matter as far as the brain is concerned. So the chip would need to calculate the wave function, create the state vector, and then simply to convey to the brain that all the states in the state vector are equally real and have been measured and 100% probability-wise, 100% probable. That would grant the brain access to all these states, and all these states are essentially computational states. Although the brain neurons are binary, they are like yes, no. Basically, they fire or they don't fire. The capacity of the brain, these 70 billion elements, when they would be placed in a quantum space, then they would become essentially qubits. Now, one of the objections that I've heard is that if I were to convince the brain, if I were to deceive the brain into believing that all the states are collapsible, all the states are reducible, and that the state vector collapses in totality, and the superposition is actually deterministically 100% reducible, and so all the states become equal collapses, and all the states are 100% probable, and so on and so forth, then I would not be in a quantum space. So the objection is that in this scenario, we would actually be in a deterministic space, in a classical space. I could even say post-Newtonian space, between Newton and Einstein. But that is not true, of course, because when you have a state vector and all the probabilities of all its components are 100, you don't end up in a Newtonian Einsteinian universe. You don't end up in a Newtonian Einsteinian space. You end up in a highly specific, highly unique quantum space, which is where chaos theory comes to the rescue. And more generally, the dynamics of complex systems, and especially attractor theories. And the ability to relate to all this as noise to signal ratios and information theory thing is very helpful, because it underlies the capacity for quantum computing in a quantum space that is 100% deterministic. Of course, the wave function is deterministic. That's the irony. The irony is that the formalism is essentially deterministic. But I will not go into it. That's for another day. So now I want to discuss a bit the philosophy behind all this. I've discussed the mathematical apparatus, and I'd like to discuss the philosophy. Our universe can be mathematically described as a matched or PLL filter whose properties let through the collapsed outcomes of wave functions when measured, or the signal. The rest of the superposition, or the other universes in a multiverse, can be represented as noise. Our universe therefore enhances the signal-to-noise ratio through acts of measurements. And that's, between you and me, a kind of anthropic principle. Anyhow, arguably, the most intractable philosophical question attached to quantum mechanics is that of measurement. The Copenhagen interpretation of quantum mechanics says that the very act of sentient measurement determines the outcome of the measurement in the quantum microscopic or microcosmic realm. The wave function, which describes the coexisting superposition states of the system, collapses following an act of measurement. It seems that just by knowing the results of a measurement, we determine its outcome, determine the state of the system, and by implication, the state of the universe as a whole. This notion is so counterintuitive that it has fostered a raging debate which has been ongoing for more than 7 decades now. And I have an interview that I granted to a Turkish journalist, and I will post the link on the description if you want to learn more about this debate regarding the measurement. But let us turn to the question, and inevitably the answer. Let's turn it on its head. Let's ask it in a different way. Is it a measurement that brings about the collapse? Or maybe we are capable of measuring only collapse results. Maybe our very ability to measure, to design measurement methods and instrumentation, to conceptualize and formalize the act of measurement and so on, maybe these render us limited. They're limited and they're designed so as to yield only the collapsible solutions of the wave function, which are macrocosmically stable and objective. These are known as the pointer states. So maybe our hardware, starting with the brain and ending with measurement instruments, which are extensions of a brain, is constructed to detect only collapse states. Indeed, pointer states are reminiscent of strange attractors in chaos theory, as I said. Most measurements are indirect. They tally the effects of the system on a minute segment of its environment. Wojciech Zurek and others proved that even partial and roundabout measurements are sufficient to induce Einselection, or environment-induced superselection. In other words, even the most rudimentary act of measurement is likely to probe pointer states. Superpositions are notoriously unstable. Even in the quantum realm, they last an infinitesimal moment of time. Our measurement apparatus is not sufficiently sensitive to capture superpositions. By contrast, collapsed or pointer states are relatively stable and lasting, and thus they can be observed and measured. This is why we measure only collapsed states, because they are the only ones there long enough for us to measure them. But in which sense, excluding their longevity, in which sense are collapsed states measurable? What makes them measurable? What makes them, I would say, unique? Collapse events are not necessarily the most highly probable. Some of them are associated with low probabilities, and yet they still occur and they are still measured. By definition, the most probable states tend to occur and be measured more often. The wave function collapses more frequently into high probability states. I grant you that, but this does not exclude the less probable states of the quantum system from materializing upon measurement from time to time. Pointer states are carefully selected for some purpose, within a certain pattern and in a certain sequence. What could this purpose be? Probably the extension and enhancement of order in the universe and a positive adaptation as far as survival. So it's an evolutionary advantage to detect collapsed states. It endows the organism with survival edge, an edge for survival. And as far as the universe is concerned, it caters to the extension and the enhancement and the accumulation of order. And that this is so can be easily substantiated by the fact that it is so. Order increases all the time, at least locally. The anthropocentric and anthropic view of the Copenhagen interpretation, that conscious, intelligent observers determine the outcomes of measurements in the quantum realm, associates humans with negentropy, the decrease of entropy and the increase of order. This is not to say that entropy cannot increase locally and order decrease or low energy states attained. But it is to say that low energy states and local entropy increases are perturbations. So low energy states and increases in local entropy are perturbations. And that overall order in the universe tends to increase even as local pockets of disorder are created. That's one way of looking at it. Of course, the opposing view is exactly the opposite. Disorder, entropy in the universe tends to increase with local pockets of order. Be that as it may, order does increase, whether locally or non-locally. Systemically, it does increase. The overall increase of order in the universe should be introduced, therefore, as a constraint into any quantum mechanic formalism. Yet surely we cannot attribute an inevitable and invariable increase in order to each and every measurement, to each and every collapse. To say that a given collapse event contributed to an increase in order as an extensive parameter, especially order in the whole universe, we must assume the existence of some grand design within which this statement would make sense. The constraint of increasing order is a design element. Even if, and again, I want to make clear and emphasize, it's irrelevant whether order increases throughout the universe as an extensive parameter of the universe, or whether it increases locally. The very fact that there are pockets which are negentropic, pockets which are contrary to the second law of thermodynamics, this very fact is very, very problematic because it implies some intervention. This constraint, especially if it's local, implies some kind of intervention. And such a grand design, such a mechanism, must be able to gauge the level of orderliness at any given moment, for instance, before and after the collapse. It must have at its disposal sensors of increasing or decreasing, local or non-local order. Human observers are such order-sensitive instruments. We have the capacity to detect an increase in order. We introduce order into the world. We enhance and increase order locally. And yet, to imply that human beings were created for this purpose, or that there is a purpose at all, you'll be beginning to see that this philosophical approach is very problematic. When we regard collapsed states as privileged states, we also at the same time postulate an increase in order, at least locally. And at that point, the act of measurement, which is by definition a conscious act when it comes to human beings, although measurement can be non-conscious, but when it comes to human beings, it's a conscious act. So at that moment, the act of measurement is actually an act of design. It's an act of intervention in the universe. And it renders physics metaphysics, a branch of mysticism. And so, strangely, when I'm talking about deceiving the brain into perceiving non-collapsed states as reduced states, as collapsed states, into misperceiving the total state vector as having been reduced in a collapsed state, at that moment I'm removing intelligence and sentience and the human mind and the act of measurement and even the act of measurement by machines. I'm removing all this from the picture at that point. If all superpositions and all state vectors ultimately collapse, all the elements in the superposition, all the eigenstates, all the states in the state vector, they all collapse ultimately, or then it reduces the need for a grand design. But when I say that they all collapse, I don't mean to say that they all happen simultaneously. Of course they don't. But I mean to say that none of them has a privileged status. Our brains are constructed to detect and to measure what we call today collapsed states. But that doesn't endow the collapsed state with any privileged status. In other words, the collapseness of the state, the fact that the state is collapsed, is not an attribute of the state, is not a characteristic of the state. It's a deformity or a design of the measuring instrument, in this case the brain. The measuring device we have, the brain, detects these particular states, not because they're special, not because they are high probability, not because there's anything innate to these states, not because they've been selected, not because they've been, none of this. It's because that's how the brain is constructed. And so if we were to tinker with the brain, with this imagined chip, PLL chip, we could actually see reality as it is. And in reality as it is, everything is. Everything is. Nothing has a privileged position. As Einstein has taught us, nothing has a privileged position. That quantum mechanics ended up positing or proposing that there are states that are privileged reflects our limitations as observers, not reality. And this chip, implanted in the brain, which will deceive the brain into seeing reality as it is, will simply restore a truly objective, deterministic quantum mechanics, which should have been the case to start with, exactly as Einstein said, God doesn't play dice. Still, even assuming that quantum states are naturally selected for their robustness and stability. In other words, for their orderliness. Let's assume, let's adopt this position, that they are somehow unique, they are somehow privileged. How does the quantum system know about this constraint of increasing order? How does the quantum system how does it know its place in the grand scheme of things? How does a quantum system know about the measurement device? In other words, the question is reversed. Not how does the measurement device interface with the quantum system, not how does a measurement device detect the collapse state. No, in my view, that's an easy one. We're built to detect the collapse state. I think the real question is, how does the quantum system know? How does the system know about the rest of the universe, about the observer, about the mind of the observer, about the brain, where is this knowledge coming from? How does the system know to select the pointer states time and again? How does the quantum realm give rise to the world as we know it? Objective, stable, certain, robust, predictable, intuitive. How? That's why I'm saying the way we're perceiving the world through quantum mechanics is wrong. It reflects our limitations as observers. It reflects the unique design of the brain, not reality. Reality can't be like this. Absolutely cannot be like this. If the quantum system has no a priori awareness of how it fits into an ever more orderly universe, how is the information transferred from the universe to the entangled quantum system and measurement system at the moment of measurement? Such information must be communicated superluminally at a speed greater than the speed of light. Quantum decisions are instantaneous. Quantum decisions are simultaneous, both in the quantum system and in the measurement system, while the information about the quantum system's environment emanates from near and far. It should take time to arrive and to be communicated. This implies that there is a basic fault, basic problem with quantum mechanics as we know it today. It's a famous problem of locality and so on. I will not go into it, but this is a strong indication. This instantaneous communication, action at a distance, if you wish, is a very powerful indication that we are misperceiving the world, or misperceiving, the mechanisms. And it can all be solved, all this is solved instantaneously, if we just assume that there's a problem with the measurement device, that our brain is biased and prejudiced in favor of collapse states. At that moment, quantum mechanics becomes deterministic. At that moment, we get rid of action at a distance. At that moment, the alleged interface between measurement device and the quantum system changes its nature so dramatically that it becomes a simple act of observation, the way I observe this computer or this lamp. It's philosophically very powerful to change our point of view. What are the transmission and reception mechanisms and channels between the quantum system, the measurement device, or the observer, and the rest of the universe? What are they? Which is the receiver? Where is the transmitter? What is the form of the information? What is its carrier? Do we have to postulate another particle to account for this last one? And another no less crucial question relates to the apparent arbitrariness of the selection process. All the parts of a superposition constitute potential collapse events. All of them can in principle be measured. Why is only one of them measured? Why is only one event measured in any given measurement? Why not all of them? How is this event, the collapse event, how is it selected to be the collapse event? Why does it retain a privileged status versus the measurement apparatus or the measurement act? It seems that preferred states have to do with the inexorable process of increase of overall amount of order locally or in the universe as a whole. If other states were to have been selected, order would have diminished. That's
the intuitive reaction. The proof is, again, in the pudding. Order does increase all the time, at least locally. And therefore, measurable collapse event and Poynter states tend to increase order. There is a process of negative order-oriented selection. Collapse events and states which tend to increase entropy are filtered out and statistically avoided. They are measured less. That's more or less the current attitude in information theory and thermodynamics. But I suggest that this is wrong. I think all events in a superposition increase order. All of them. There's no event which increases entropy. By virtue of occurring and being measured, order is added to the system. The event may decay later. Obviously, the event may be subject to the second law of thermodynamics and increase entropy later. But at the moment of measurement, there's an increase in order. So all the events are identical in the face of the constraint of increasing enhanced order. Order cannot be the reason we select specific or we measure specific collapse states. It has to do with the act of measurement, or more precisely with the measurement device. It cannot have anything to do with the universe, with the physics. It has to do with the specific interaction. We seem to have a machine, a device called the brain, which detects only collapse states. There seems to be a guiding principle, that of statistical increase of order in the universe. I agree, locally, I agree with it. This guiding principle cannot be communicated to quantum systems with each and every measurement, because such communication would have to be superliminal, which presents a problem. The only logical conclusion is that all the information relevant to the decrease of entropy and to the increase of order in the universe is stored in each and every part of the universe. It's a fractal approach, which is why I'm using strange attractors. Chaos theory, strange chaotic attractors. So no matter how minuscule, no matter how fundamental the part of the universe is, it contains this information relevant to the decrease in entropy and increase in order locally. That is true in my view, but it also says that all the states in the state vector, all the parts of the superposition, all the eigenstates and so on, they all must be subject to the same constraint. They all increase order at the moment of measurement. And I think it is the very act of measurement that introduces the order. Order increases locally by virtue of measurement, by virtue of measuring. It's not something inherent and innate in the states, in the collapsed or non-collapsed states. It is in the act of measurement. Order emanates from the observer. The observer does not determine the event. The observer does not create the particle. This is metaphysics or mysticism. But the observer does do. The observer is the one who introduces the constraint of increasing order locally. How? By measuring. And because there is this constraint, we measure only collapse states. Because there is this constraint, we measure only collapse states, because collapse states are stable. But the truth is that all states in the state vector increase order locally. However, they decay very fast. And so the net increase is in disorder. The non-collapse states, or the states that are not detected by the measurement devices or the brain, because they don't last long enough, they're not stable enough, and so they're not collapse state. These other states decay and degenerate very fast. So they tend to add negentropy, they tend to add entropy. Whereas the collapse state maintains negentropy. I'm sorry, the non-collapse states increase entropy because they decay and degenerate very fast. Whereas the collapse state increases negentropy because it is stable in the long term. So non-collapsed states increase entropy, collapsed states increases negentropy, fights off entropy and increases order. This is why we have a predilection, where we have a selective filter, a preference for detecting these stable negentropic states, which are erroneously called collapsed states, because all states are collapsed. They're just not detectable as such by the brain. When you have a machine, when you have a measurement device, when you have the brain, which are operating under the constraints of locally increasing order, they will detect only order increasing states. So they will detect what we call collapse states. All the other states collapse as well, but they contribute to noise. The increase in order is so brief, and then there is a lot of entropy. And I think that's the reason we detect only what we call collapse states. It is safe to assume that, very much like in living organisms, all the relevant information regarding the preferred order favoring quantum states is stored in a kind of physical DNA. The unfolding of this physical DNA takes place in the physical world during interactions between physical systems, one of which is the measurement apparatus or measurement device or the brain. Biological DNA contains all the information about the living organism and is replicated trillions of times over in each and every cell. It is stored in the basic unit of the organism, which is the cell. What reason is there to assume that nature deviated from this very pragmatic principle, fractal principle if you wish, in other realms of existence? Why not repeat this winning design, for example, in elementary particles? The biological variant of DNA requires a biochemical context and environment to translate itself into an organism. This environment is made up of amino acids and so on. The physical DNA probably also requires some type of context, the physical world, as revealed through the act of measurement. The information stored in the physical particle or event in the Chronon field theory is structural because order has to do with structure. Very much like a fractal or a hologram, every particle reflects the whole universe accurately, and the same laws of nature apply to both. Consider the startling similarities between the formalisms and the laws that pertain to subatomic particles and black holes. Moreover, the distinction between functional, operational, and structural information is superfluous and artificial. There is a magnitude bias here. Being creatures of the macrocosm, form and function look to us distinct. But if we accept that function is merely what we call an increase in order, then the distinction is cancelled, because the only way to measure an increase in order is structurally. We measure functioning, the increase in order, using structural methods, the alignment or arrangement of instruments, measurement instruments. Still, the information contained in each particle should encompass at least the relevant, close, non-negligible, and non-cancelable parts of the universe. This is a tremendous amount of data. How is it stored in such tiny corpuscles or such tiny events? Well, I don't know. Either utilizing methods and processes which we are far even from guessing, or else the relevant information is infinitesimally, vanishingly small, actually. The extent of necessary information contained in each and every physical particle could be somehow linked or even equal to the number of possible quantum states, could be linked somehow to the superposition. Superposition may be a reflection of this DNA. The collapse event, as we perceive it, is non-representative in the sense that non-representative because it's not privileged, is what I'm trying to say, because all other events are the same. They contain essentially the same information. It may well be that the whole universe can be adequately encompassed in an unbelievably minute, negligibly tiny amount of data, which are incorporated in those quantum supercomputers that today, for lack of better understanding, we call particles. And in the Chronon field theory, they are events. in a field of potentials. So this is where my mind is going right now. As you see, there are several possible directions. Some of them are mutually exclusive, contradictory. I'm not pretending that I have the answers. I'm just sharing with you my deliberations and my internal arguments and so on and so forth. It's going somewhere. I know it's going somewhere because the mathematics is coalescing. I'm already able to put together some basic modules and units of the mathematics, and they give interesting results. For example, the affinity between attractors of all kinds and eigenstates, states in the state vector, is pretty amazing. And there are specific attractors that are identical to pointer states. So I'm beginning to see that chaos theory and similar mathematical work, attractor theory, can fit into this. I'm doing a lot of work with noise and signal, especially probabilities of noise and signal. And then I'm trying to map the state vector into noise and signal kind of templates to regard some states as noise, some states as signal. I'm going in a variety of directions, but I have the feeling that we are misperceiving reality. We are misperceiving reality because of our limitations, the limitations of the devices that we built to probe reality and learn its true nature. And I think we need to step back and rethink the whole thing. Perhaps one of the ideas that I gave here. The same way, in 1982, I stepped back, having spoken to Yakira Aronov and Richard Feynman at length. I stepped back in 1982 and I said, we need to rethink the whole of physics. There is a multiplication of entities. There's no parsimony. Something is wrong here. And then I came up with Chronon field theory and with the idea of fields of potentials, events, and so on and so forth, which a theory which has been developed unrecognizably by Eitan Sachad. I think I'm leading somewhere with this, and I think I'm going to come up ultimately with a quantum theory that would be deterministic and would allow us to get rid of the biases and prejudices and limitations that currently plague the measurement problem and the measurement acts, simply because never mind how hard we try, we end up in the brain. And we need to take a hard look at the brain. And we need to get rid of the assumption that the brain is infinite and capable of anything and everything. No, it's not. It's limited, very. And we need to not be blind to these limitations. To the best of our ability, attempt to remove them. And mathematics is the way to go initially. Because whatever else you say about mathematics, it's divorced from any substrate. It is divorced from any platform. It's not dependent. While the act of measurement in the physical world is most definitely dependent on the brain and the brain children of mankind.